let's take a look at signed integer multiplication. Just to be on the safe side, I'm declaring N1 and N2 as signed words. In other words, 16-bit values that can be negative as well as positive. And I'll set N1 equal to negative 150. Once again, I'll clear out the EAX and the EDX registers. Then I move N1 into the AX register, and now I can use a different multiply instruction. The little I in front means signed integer multiplication. Remember that with signed integers, we give up the most significant bit and use it as a sign. This integer multiply instruction retains the sign bit when it multiplies. So if I multiply a positive times a negative, I get a negative answer. Or if I multiply a negative times a negative, I get a positive answer. And finally, if I multiply two positive values, I get a positive answer. After the multiply instruction on line 20, look what the AX register contains. If this left bit has a number 8 or larger, it means the number is negative, when you're talking about signed integers anyway. So the AX register contains negative something. Look at the carry flag. It's clear, so I know the AX register contains my entire answer. But look at the DX register. It contains all F's in hex, which means all of its bits are set to 1. In other words, the bits in the DX register are copies of the most significant bit in the AX register. On line 21, I'm showing you that you can check to see if the carry flag was set or not. If you need to know whether or not the result of a multiply instruction is contained entirely in the AX register, here's how you can check. If the carry flag is clear, you know that you could store the AX register into a 16-bit variable. On the other hand, if the carry flag is set, you know you'd have to do the trick of shifting the EDX register 16 bits to the left and then adding it to the EAX register like we did before. In fact, that's probably the best approach to take when multiplying two 16-bit variables. Just assume you're going to need all 32 bits for the answer and combine the EAX and EDX registers into EAX like we've done with the shift and add instructions. But if you needed to know whether or not the answer is contained in just the AX register, you can check for that too. In this example, the negative 3,750 can all fit in just the AX register. So the program doesn't take the jump on line 21. Instead, it stores the AX register into a 16-bit value named W results. Let's change that up just a little bit. Here, I'm going to multiply negative 5,000 times 128. I should get negative 640,000 for an answer, which isn't going to fit into the AX register. So I step through the code and do the multiply instruction on line 20. Now look at the carry flag. It's set, so the program takes the jump on line 21. Then it goes through the process of combining the EAX and the EDX registers into one 32-bit answer. This answer gets stored into a signed double word variable named DW result. Let me change the display so that you can see that we actually did get the right answer. As I said before, it's probably better to just go ahead and assume you're always going to need the 32-bit answer, so this checking the carry and everything usually won't be necessary. You'd only use it if you want to check to see if the answer is contained entirely in the AX register. But are you in for a bargain? Because the x86 assembly language gives you not one, not two, but three versions of the signed integer multiply. We just looked at the first one, and it acts pretty much like the unsigned integer multiplication. We better take a look at the other two. Version 1 is what we just looked at. Version 2 lets you have two explicit operands and no implicit operands. That causes two changes. Number one, you're not tied to the EAX or the AX or the AL registers anymore. And number two, you can have an immediate value as one of the operands. Both of those changes really broaden your horizons when it comes to signed integer multiplication. Version 3 lets you use 3 explicit operands and no implicit ones. One of the explicit ones can be an immediate value. In this third form, the two operands on the right multiply together, and then the result is stored into the operand on the left, which can be any register you choose. Here's some examples of those in Visual Studio. This is an example of version 2 of signed multiplication. I'm loading one of my values into the BX register, and then on line 18, I'm using 2 explicit operands to multiply. The result will be stored in the BX register. But this version of the multiply changes something else too. Now, if the carry is set, you've just got an invalid answer that won't fit into the destination register. So you have to check for that. I'm doing that on line 19. Notice if the carry is set, the program jumps to line 23, where I might have some code that either sets an error code or prints an error message or something like that. Otherwise, on line 20, I can just store my results. And here you can see that the negative 1,175 is the correct answer. Here's what version 2 might look like if my result won't fit into the destination register. I'm multiplying 2,500 by negative 47, and I should get negative 117,500, which isn't going to fit in the BX register. After the multiply instruction on line 18, look what happened to the BX register. That 3504 hex equals about 13,600, not the negative 117,500 that it should. It couldn't. So on line 19, because the carry flag is set, the program jumps to line 23 and can just deal with an invalid result. That sound you're hearing in the background is my dog Sunny working on a bone. As I've said before, she's invaluable in making these videos. The last example in this video shows the 3 operand version of the signed integer multiply. Notice it has 3 explicit operands. Here I want to multiply the 750 stored in the num1 variable by negative 30. I should get negative 22,500 as a result. So on line 18, I multiply 750 stored in the CX register by negative 30. The important thing to notice here is that the negative 30 is an immediate value. After the multiply instruction on line 18, take a look at the carry flag. It's clear, so I know I've got a good result. That means the jump on line 19 is not taken, and I can just store my results on line 20. Notice that we get the correct answer stored into our result variable. Like I said at the start of this video, integer multiply is more involved than integer add or subtract. As you're learning how to use assembly language to multiply integers, the debugger can be your best friend. You'll scratch your head and try to figure out why answers came out so wrong. When that happens, step through your code looking at the register changes and at the carry flag. Those will be the quickest signs where something went wrong. Let's call this one done. Thank you, Sunny, for your help, and thank you all for watching.